Hello dear learners, welcome to the World of Chemistry YouTube channel. In this class, we will discuss about the Bohr's model for hydrogen atom. In our previous class, we studied the discoveries that led to Bohr's model such as electromagnetic waves, Planck's quantum theory, photoelectric effect and atomic spectra. Today, we are going to study one of the most important models in the chemistry, the Bohr's atomic model. So this model was proposed by Niels Bohr in 1913. Bohr combined Rutherford's nuclear model with Planck's quantum theory and successfully explained the structure of the hydrogen atom. Most importantly, he explained why atoms are stable and why hydrogen produces line spectrum. So now let us understand how Bohr solved these problems. Okay, so in this Bohr's model for hydrogen atom, the learning objectives are postulates of Bohr's model, results obtained from Bohr's model, explanation of line spectrum of hydrogen, limitations of Bohr's model. Okay. First we will discuss postulates of Bohr's model. Introductions to Bohr's model. Okay. So now, what are the general features of the structure of hydrogen atom of an spectrum is explained here. So what we will discuss here means, so he is a Niels Bohr. So he born in 1913. So he was a Danish physicist who made an important contribution to our understanding of atomic structure. So before Bohr's model, Rutherford explained that an atom contains a small positively charged nucleus. However, Rutherford could not explain why electrons do not fall into the nucleus. So Bohr solved this problem by proposing that electrons move around the nucleus in a fixed circular path called orbits or energy levels. In the hydrogen atom, there is one proton in the nucleus and one electron revolving around it. So Bohr's model successfully explained the structure of the hydrogen atom and also explained the hydrogen line spectrum, which is produced when electrons move from one energy level to another. So in this chapter, we'll learn these postulates, energy levels, hydrogen spectrums, and the limitations of this model. Okay, the first postulate is here. Okay, so according to Bohr, electrons revolve around the nucleus only in a certain fixed circular path. Okay, in a fixed circular paths called orbits. So these orbits are represented by n. That is n equals to 1, n equals to 2, n equals to 3 and so on. So each orbit has a fixed radius and fixed energy. Therefore, electron cannot stay between two orbits. Electrons cannot stay between two orbits. The orbits nearest to the nucleus, n equals to 1 has the lowest energy. So this n equals to 1 has the lowest energy. As we move further from the nucleus, the energy of the orbit increases. As we move further from the orbit, the energy increases. So the Bohr also proposed that while an electron moves in these fixed orbits, it does not lose energy. As electron moves in these fixed orbits, it does not lose energy. So here this solve the major problem of the Rutherford's model. So which could not explain why electrons do not fall into the nucleus. Therefore, Bohr explained the stability of the atom through fixed energy orbit. So here which one has the lowest energy? This n equals to 1, the first orbit. So electrons revolve around the nucleus in a fixed circular orbits having definite energy and radius. So this is our first postulate. Moving to the second postulate, what it says, so according to Bohr, an electron remains in its orbit and does not change its position unless energy is absorbed or released. Okay, what it says, an electron remains in its orbit and does not change its position unless energy is absorbed or released. So now here, when an electron gains energy or absorbs energy, it jumps from lower energy to the higher energy level. So when electron gains or absorbs energy, it jumps from lower energy to higher energy. For example, we can say, the n equals to 1, n equals to 1, n equals to 1 to n equals to 2, or n equals to 2 to n equals to 3. So this process is called excitation. This process is called excitation. What it is here is, when an electron gains energy or absorbs energy, it jumps from lower energy to higher energy levels. So that will be from n equals to 1 to n equals to 2, or n equals to 2 to n equals to 3. So this process is called excitation. Okay. So now here, when an electron is in higher energy level, it is unstable. When electron is already in the higher energy level, it is unstable. So it returns to lower energy by losing or emitting the energy in the form of light. So what happens? It emits energy. Okay. For example, we can say that from n equals to 3 to n equals to 2, or n equals to 2 to n equals to 1. Okay. So this process we are calling as de-excitation. So the emitted energy appears as a photon of light and produces the hydrogen spectrum. So for example, here we can say that, you can think of a climbing stairs to go from lower step to a higher step. you need energy. But to come down, energy is released. Similarly, electrons absorb energy to move up and emit energy to move down. Okay, I hope you understood. So when you are climbing the stairs, when you are climbing the stairs, to go from lower step to a higher step, you need energy. But to come down, energy is released. So in the same way, electrons absorb energy to move up and emit energy to move down. Okay. So what we understood from this postulates, electrons absorb energy to jump to higher orbits and emit energy when they return to lower orbits. Okay. The third postulate is here. The third postulate here. So according to Bohr, whenever an electron moves from one orbit to another orbit, move from one orbit to another orbit, energy is either absorbed or emitted. Energy is either absorbed or emitted. Okay. So the frequency of the radiation depends on frequency of radiation depends on energy difference between energy difference between initial orbit and the final orbit. Initial orbit and final orbit. Okay. So the mathematically they have given the equation here. So nu equals to delta E by H there, or we can say nu equals to E final minus E initial divided by H. Okay. So this nu represents frequency of radiation. Okay. So delta E is a change in energy. And H is, we know that it is a Planck's constant. Okay. So this equation tells us that the larger energy difference produces radiation with higher frequency. The larger energy difference produces radiation with higher frequency. When an electron jumps from lower orbit to a higher orbit, it absorbs energy. Okay. So when an electron jumps from a higher orbit to a lower orbit, it emits energy in the form of light. So the emitted light produces the hydrogen line spectrum. So the emitted light produces hydrogen line spectrum. Okay. So suppose an electron moves from n equals to 3 to n equals to 3 to n equals to 2, the electron lose energy and emits a photon of light. So if it moves from n equals to 1 to n equals to 3, it must absorb energy. It must absorb energy. So thus, electron transitions are responsible for the absorption and emission of the spectra. Electron transitions are responsible for absorption and emission of the spectra. Okay. So what third postulate says here? The third postulate says the frequency of the emitted or absorbed radiation depends on the energy difference between two energy levels. Energy difference between two energy levels. Now the fourth postulates here. So the fourth postulates of Bohr atomic model called the quantization of angular momentum. What it is called? The quantization of angular momentum. So the Bohr proposed that an electron cannot move in any random orbit around the nucleus. Okay. So it can move only in those orbits where its angular momentum has certain fixed values. So this itself we can written mathematically as mvr equals to nh by 2 pi. Okay. So whereas this m is mass, this m is mass of a electron, mass of electron. This v is velocity of electron, velocity of electron. So this r is radius, r is a radius. Okay. So this h is Planck's constant, Planck's constant. So this n is principal quantum number. This n is principal quantum number. Where n equals to 1, 2, 3, 4, so on. So this quantity, the quantity mvr is called angular momentum of the electron. This mvr is called angular momentum of the electron. Okay. So according to Bohr, angular momentum must be integral multiple of angular momentum must be integral multiple of h by 2 pi. H by 2 pi. So therefore only specific orbits are allowed and electrons cannot exist between these two orbits. Okay. Electrons cannot exist between these two orbits. Now you can think of a staircase. Okay. You can stand only on one step, not between the steps. Okay. You can stand only on the steps, not between the steps. So in the same way, electrons can stay only in certain allowed orbits. Okay. Not in between them. So that is why the energy of electron is quantized. The energy of the electrons is quantized. So here you can see this diagram. What this figure says is the electron of mass, the electron of mass me is moving with velocity v The distance from the nucleus to the electron is r. So the product mvr gives the angular momentum. So what's happening here? The electron of mass m moving with velocity v. The distance from the nucleus to the electron is r. The product mvr is the angular momentum. So only those orbits satisfying the equation mvr equals to nh by 2 pi are allowed here. Only. So here we have one problem. So which of the following cannot be the value of angular momentum of electron in hydrogen atom? So according to Bohr model, the angular momentum of an electron is given by, angular momentum can be given by mvr equals to nh by 2 pi. So where this n can be, n equals to 1, 2, 3, 4 and so on. So this means that the allowed values of angular moments are for n equals to h by, for n equals to 1, that becomes h by 2 pi, where n equals to 2, 2h by 2 pi. That means h by pi. So when n equals to 3, this will be 3h by 2 pi. When n equals to 4, this will be 4h by 2 pi, or it will be 2h by 5. So now we can compare these values with options. So this is allowed, but here this is 4, 5. So this cannot be allowed. So here the D option also allowed. So why this C is not allowed? Because 3h pi, 3h by 4 pi cannot be written in the form of nh by 2 pi, where n must be a whole number. This must be a whole number, okay, or integer. So this is the problem. Okay. Now, so what are the results obtained from the Bohr's model of atom? Okay, so first Bohr proposed that electrons exist only in certain fixed orbit around the nucleus. Electrons can exist only in certain fixed orbits around the nucleus. So these orbits are represented by n equals to 1, 2, 3, 4 and so on. So the value n is called, this value n is called principal quantum number. This is called principal quantum number. Principal quantum number. Okay. So as the value of n increases, the electrons move further. The electrons move further away from the nucleus, and its energy also increases. As the value of n increases, the electron moves farther away from the nucleus and its energy also increases. So for example, when it is n equals to 1, the first orbit, k shell. When n equals to 2, second orbit, L shell. N equals to 3, M shell. Okay, M shell. So the Bohr derived an equation. For the radius of the nth orbit. for the radius of nth orbit. Nth orbit. So this is the equation Rn equals to n square a naught, where this Rn is radius of nth orbit. Radius of nth orbit. So n is a principal quantum number. N is a principal quantum number. Quantum number, where a naught is a 52.9 picometer. So this is the radius of first orbit of the hydrogen atom. This is the radius of the first orbit of the hydrogen atom. So from the equation we can see that radius is proportional to the square of n. Radius is proportional to the square of n. Therefore, as n increases, the orbit becomes much larger. As n increases, the orbit becomes much larger. Okay. So these are the results. So here we can calculate the, here only we can calculate the radius of the first few orbits. Radius of first few orbits. Suppose n equals to 1, n equals to 1. So putting the values here, R1 equals to, n is 1, 1 square into 52.9. So the result will also be 52.9 picometer. When n is 2, when n is 2, it will be 211.6 picometer. So that is 2 into 52.9. Okay. So you can calculate for n equals to 3. Okay. So now you can see that the radius increases rapidly as we move to the higher orbits. So what this diagram says here, in the diagram the arrow is marked represents the Rn. So Rn represents the distance between the nucleus and the electron. Nucleus and the electron. So this distance is called radius of the orbit. This distance is called radius of the orbit. Radius of the orbit. So higher energy levels have larger radii. Higher energy levels have larger radii and are farther from the nucleus. Okay. So I can ask you one question. So if an electron moves from n equals to 1 to n equals to 3, will the radius increases or decreases? If an electron moves from n equals to 1 to n equals to 3, will the radius increases or decreases? Okay, so it is increases. Okay, higher orbit means larger radius. So what we can say here is the stationary states of electrons, are represented by principal quantum number, and the radius of the orbit increases as n square. So here we have energy of an electron in different stationary orbits of the hydrogen atom. Different stationary orbits of the hydrogen atom. So according to Bohr's model, each orbit has a fixed energy. Okay, each orbit has a fixed energy. The energy of an electron in the nth orbit, the energy of the electron in the nth orbit can be given as E n equals to R h by n square. Here it will be minus, okay, minus E n equals to RH by n square. So, or we can also write it as En equals to, where RH is a Rydberg constant, so we can write it as 2.18 into 10 to the power of minus 18 Joule. So, Rydberg constant. So, we can also write it as minus here, okay, minus 2.8 En equals to minus 2.18 into 10 to the power of minus 18 Joule, okay, minus 18 Joule, minus 18 Joule, okay. This will be 1 by n square. Okay. So where this n is principal quantum number, RH is a Rydberg constant. The Rydberg constant is 2.18 into 10 to the power of minus 18 Joule. So this is the energy of the first orbit. So here one thing we can notice that all the energies are in negative. All the energies are in negative, minus, okay, minus, 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 okay. So the negative sign indicates that the electron is bound to the nucleus and energy must be supplied to remove it from the atom. Negative sign indicates that the electron is bound to the nucleus and energy must be supplied to remove it from the atom. So here E1, okay, E1. So for the first orbit, E1 equals to minus 2.18 into 10 to the power of minus 18 Joule. So this is the lowest energy state of the hydrogen atom. This is the lowest energy state of the hydrogen atom and is called ground state, and is called as a ground state. Okay, ground state. Here E equals to 2. When it is E equals to 2, that N will also become 2. So the value will be minus 0.545 into 10 to the power of minus 18 Joule. So this energy is less negative than E1. This energy is less negative than E1. So therefore, the electron in the second orbit has higher energy than the electron in the first orbit. At last, E infinity. So this equation, when n approaches infinity, E infinity equals to 0. When n approaches infinity, E infinity will becomes 0. This means the electron is completely free. The electron is completely free from the attraction of the nucleus. The electron is completely free from the attraction of the nucleus. Therefore, zero energy corresponds to a free electron at rest. This corresponds to the free electron at rest. Okay. So, as the value of n increases, radius increases, energy also increases. electrons move farther from the nucleus. So the energy becomes less negative and gradually approaches zero. So one examples we can discuss here is, so we can think of a deep well. An electron in the first orbit is at the bottom of the well. To take it out, we must supply energy. When the electron reaches infinity, it has escaped completely from the atom. Okay, completely from the atom. So overall we can say here is the energy of an electron in hydrogen is inversely proportional to the energy of the electron the energy of an electron in hydrogen is inversely proportional to n square, and the energy becomes zero, when the electron is completely free from the nucleus, So moving to the next. So what it is here, the velocities of the electron moving in a stationary orbit can be calculated as. So the velocity of an electron moving in a stationary orbit. So according to Bohr's model. So Bohr derived an equation to calculate velocity of an electron in the nth orbit. So this is the equation, 2.165 into 10 to the power of 6 Z by N meter per second. So this Vn represents velocity of an electron, Z represents atomic number, N represents principal quantum number. So for hydrogen atom, Z equals to 1. So this V represents the velocity of electron, This Z represents atomic number, and N represents principal quantum number. Principal quantum number. When Z equals to 1, the first important point is, now we can see the relationship. So this means that the velocity is inversely proportional to the principal quantum number. The velocity is inversely proportional to the principal quantum. As the value of n increases, the velocity of the electron decreases. As the value of n increases, the velocity of the electron decreases. For example, n equals to 1, maximum velocity, when n equals to 2, lower, when n equals to 3, even lower velocity. So electrons move fastest in the first orbit. So here the second relation is, this means the velocity is directly proportional to the atomic number. As this atomic number increases, the attraction between the nucleus and the electron increases. As the Z increases, the attraction between the nucleus and the electron increases. Therefore, the electron moves faster. For example, hydrogen, Z equals to 1. Okay, lower velocity. When it is helium, that will be 2, the higher velocity. So when it is lithium, plus 2, it will be 3, even higher. Okay, even higher velocity. Okay, understood? So if an electron moves from n equals to 1 to n equals to 3, what happens to the velocity? If an electron moves from n equals to 1 to n equals to 3, what happens to the velocity? It decreases. Okay, so velocity is inversely proportional to the n. So according to Bohr model, electron velocity decreases with increasing the orbit number and increases with the atomic number. Decreases with the increasing orbit number and increases with atomic number. Okay. So according to Bohr model, the radius of an electron of the orbit is given by Rn equals to 52.9 n square by z picometer. Okay. So whereas this n is the orbit number and z is the atomic number. Okay. So therefore the radius of the third orbit of the hydrogen atom is increases. Maximum increases we can see. Okay, so understood all about this. So okay, so we know that here the radius of the hydrogen is given by Rn equals to 52.9 n square by z picometer. Okay, so where this n is the orbit number and z is a atomic number. When z equals to 1, what we have to do? And n equals to 3, so this it is 52.9, where n is 3 square, z is 1 picometer. This will be 476 picometer, 0.1 picometer. Therefore the radius of the third orbit of the hydrogen atom is 476.1 picometer. Okay, so this is all about the Bohr's model of an for the hydrogen atom. So thank you for your patience. Please visit again to the